Now, project network, normally what I do is I teach everything at the same time, including the forward scan and backward scan, but because it's Friday, I thought I'll give you a shorter lesson. We'll just do one thing, forward scan. So if you actually keep this, your network with you, because I am actually going through the network, I'm going to do a forward scan and a backward scan. So, and show you the critical path. So at the moment, I'm just going to show you two things. One is the earliest starting time, and the other one is forward scan. How do you do that? All right. Project network is really useful in terms of doing project management stuff. I've used it quite a bit when I was doing my work as an engineer. So thinking about project and how you organize it, how you schedule it. So what I really want out of today for you is to understand what a project network is, and you should be able to analyze a project network to determine the earliest start time or earliest starting time, EST, using forward scanning. So please know EST stands for earliest start time, and we are going to use forward scanning. Now, a project network is actually a directed graph or digraph. It's a series of vertices, nodes, and edges or arcs to represent tasks or activities required to complete a project within a certain time. So one example of a project network is a construction of a house. The networks show the activities with a sequence. The foundation of a house must be laid before any flooring can be laid. So you cannot have any flooring before the foundation of the house. And then another example is making a cup of coffee. There are a series of activities of tasks one needs to follow before you can make a cup of coffee. All right, let's use this as an example. All right, so if we think about making a cup of coffee, there are things like you have to fill the kettle, you got to boil the water, and then add water to your tea bag, right? Now, you also need, while you're boiling the water, you also have the time that you could do things like empty the teapot, rinse the teapot, and add tea leaves and that sort of stuff. All right? So in a project, in a network representing a project, each activity is represented by an edge, all right, or an arc, shown by the line with an arrow. So this is one project, this is one project, this is one project. Empty teapot is one project, rinse teapot is one project, add tea leaves is another project. All right? The activity is labeled using a letter and the time is marked on the line. All right, I'll show you a little bit later. Actually, now I'll show it to you now. For example, this one. A is project A. You will have a table describing it. And then 3 is maybe 3 days, 3 minutes, or 3 hours. All right, that sort of stuff. So in this case, what I haven't done is I haven't actually named all this in terms of an alphabet. I just put in a few kettle, 0.5 of a minutes, sort of. Each vertex or node is shown by a circle. The vertices represent the event for the start and the end of the particular activity. So if you look at this, this is the start of the activity filling kettle, end of the activity filling kettle. So you take about 0.5 of a minute. Boil water, when you start doing that, that's about 5 minutes to boil the water. While you're doing that, you can empty the teapot, start emptying the teapot, about half a minute of doing that, rinse the teapot, 1 minute, and add tea leaves, another half a minute. And then when the water is boiled, you add boiling water. All right? So these are the sequences of events. All right? Now, the type of network connection, you need to know what the word the preceding event means. So event B is preceded by A, which means A must happen before B. All right? B happens after A. So the word precede is important, or preceding event. Event B is preceded by A, which means A must happen before B. All right. More than one activity with the same preceding event. Here you can see that B and C can only happen after A. So you say that event B and C are preceded by A. One preceding event could be two preceding events. All right, keep going. Now, activity with more than one preceding event. So event I is preceded by F, G, and H. So F, G, and H must happen before I can happen. So you have to, for example, boiling the water and put the tea leaves into the teapot before you can make the tea. So the two events must happen first before the third event can happen. All right, happy with it? Then we can move on. All right, this is vocabulary that you need to know, predecessor. So, sorry? Yeah, I will leave it on. So vocabulary you must know is predecessor. So the predecessor for B in this situation, one preceding event, the predecessor for B is A. Here the predecessor for B and C is A. The predecessor for I is F, G, and H. So the word predecessor is important. It will be used in the question. Happy for me to move on now? Okay, no problems. All right, let's go. Move on. Now, have a look at this. This is actually the task taken to cook a pizza and serve it. So you would have a task list, the time taken, and the order of the task. All right. So for example, heating oven, making dough, washing vegetables, preparing toppings, rolling dough for base, placing toppings on base, cooking pizza, slicing and serving. So here, A, B, and C can all start at the same time. You can think, heating the oven, as soon as you switch the oven on, you can start making the dough, all right, putting the yeast with the flour and everything, and then you can wash the vegetable. So all three can start at the same time. And then you guys think about D must follow C. You cannot prepare the topping until you wash your vegetables. So that is the order of tasks. E must follow B. You cannot roll the dough if you don't make the dough, correct? Yeah? But those two, washing vegetables and preparing topping, is actually, both of them are independent from making the dough and rolling the dough. Right? Yeah? So therefore you can see that B and E is in a different path, and A and D is in a different path, because they are independent events. However, G, cooking pizza, you cannot, F, placing the topping on the base. You cannot place any topping on the base until you have done rolling the dough and preparing the topping, right? So the sequences is, you can do this at the same time, parallel, which is B, making dough, washing vegetables, and then rolling the dough and preparing topping at the same time. Not that you can split yourself into two in doing both, but you should show this as a project network because this is how it will go. And heating oven, yes, is another parallel project to that, because you need to heat the oven before you can put all this in. Then you put the topping, place topping on top, and then see here, F must follow B, C, D, and E. So if E and D does not happen, F cannot happen. So those are the predecessors of B, C, E, and D. They are the predecessors of F. All right, and then G. These are all the predecessors of G. Cooking the pizza, and then slicing and serving. And that's the end. Start and the end. So the focus question for us is, how do we determine the minimum completion time? And what are the activities which must start on time? Is it possible for some tasks to start later? So what we need to do is think about what is the earliest starting time using forward scanning. So you can see that, I mean, like I said, we can't split ourselves into three. We can't start everything at the same time, right? Some of it can start a little bit later. So therefore, we got to think about what are the activities which must start on time, which could start a little bit later. All right. So those are the things important when we are looking at the parallel lines. All right. So all the parallels project going. Some of that you must start it straight away. Some of that you can start a little bit later. All right. So I've got the network in front of you. I want you to have a quick look at this project. So you can, for example, A, straight away you can answer, how many activities are required to be completed for this project? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them. Each ages or each arc is one activity. So straight away you know what that is. Now, let's not worry about the critical path yet, because I'm going to show you the critical path on Monday. All right? And then the critical activities and that sort of stuff. Right? So what I'm going to do is I'm going to show you forward scan, as in going from the start to the finish to find the earliest start time. Backward scan is going from back to front to determine the latest start time. All right, now systematic approach. You must work from the start to the finish in the direction of the arrows and in the top half of each vertex. Record the earliest starting time or earliest start time, EST, for every activity or every task in the network. The earliest start time is the least time taken to reach this stage in the project, with all previous tasks in the same path completed. All right? Sounds a bit mumble jumble, but I'll show you what to do. Now, let's start forward scan. Determine EST. At the start vertex of the node, enter a 0 at the top of the vertex. All right? You've got a circle there. This is a start. You enter a 0. All right? There. You need a top and a bottom. The top number is what you call the forward scan. All right? We'll look at the backward scan on Monday. So the earliest starting time for any task is the maximum time taken to reach the task. Therefore, when two or more edges or arcs or path joins the vertex, the highest total time is chosen as the ESD. Enter the ESD in every node. The entry in the final finishing node will give you the minimum completion time for the project. Don't worry about copying this down, because I'm going to give you a printout of the forward scan and backward scan procedure a little bit later. Both of them at the same time. All right? Now, let's start. So here, the forward scan example. I start off with putting a 0 at the start. You know this is starting point, this is the ending point. You always go from left to right. All right? Starting point, ending point. I haven't seen any question going that way, the arrow pointing that way, so it's always from here. Just look at where the arrows are pointing. All right? You can see that at this vertex here, there is nothing else coming in, correct? There's only A going in. A has to start before D can start, correct? So therefore, at this point, the maximum time is 6. Let's say 6 minutes. Now, then if I do that, I've got 2 activities got to start before this can start. So I cannot do this node yet, or this vertex yet. I have to look at this. All right, B and C parallel. Correct? Yeah? Now, before E and F can start, you know that C and B must complete first. Correct? How long does B take to complete? 12 minutes, maybe, or 12 days, or whatever. I didn't have the time, so it's 12. What about C? 14. So where should they be? What number should that be? 14, because B, you can see that we may not have to start at the same time, correct? We have the time, or we call it slack. I'll talk to you about the word slack a little bit later. This, you can move a little bit later, correct? Whereas C, which is 14, you must start straight away, and it will take 14 minutes for C to finish, whereas B is 12 minutes, right? So therefore, you write the 14 there. All right? So if 2 things going into one, you got to think about what is the maximum. All right? The largest number go in. Now here, 14 to 16, there's only 1. You can write down 14 plus 16, that's 30 straight away. Whereas here, you got to think about it. 6 plus 21 is 27. Whereas 14 plus 18, that will give you 32. So 32 over here and 30 over there. All right? Now again here, between here and here, you know at this point, I've already used up 32 minutes. I used up 30 minutes. From here to here, I need to add 11 minutes, which is 43, whereas that will be 32 minutes. So you need to put in the maximum of 43. All right? And then, of course, follow. 32 plus 12 is 44, whereas this one will be 50. 60, sorry. So the earliest you can complete this, say if everything is minutes, will be 60 minutes. If it is day, will be
What about B?
sorry, B.
What about B? You still need to complete it.
Oh yeah, you still have to complete it, but you are doing it at the same time, correct? You can have those things doing it. For example, one is making dough, the other one is washing a vegetable. So making dough, once you start making it, you can leave it aside, and the other one, you do it at the same time. You may have 2 people doing it, so it could be one person doing something, the other person doing the other. Very typical question, because one of the questions they will ask is, you've got so many people doing it, if we've got one less person, what could we do? All right, this sort of question. Good question, thank you, Laura. So now, the completion time for this project is 60 hours. Let's say everything is hours. All right, completion time 60 hours. And then, here, I wrote down, 32 is written into this note because task A, B, C, and D must be completed before G and H can start. Therefore, the earliest starting time for task G and H is 32 hours into the project. All right? So what I want all of you to do today is just to be able to work on the forward scan. Work out what is completion time. Parallel project, you may have 2 people doing it, you may have 3 people doing it. All right? You will have questions. I'll go through questions in the exam, how we will look at resourcing it. So at this stage, assume that you can split yourself into two, or you can have many, many people working on one project. With the parallel project, make sure that you can have the maximum time as the earliest starting time. All right? Any question before I move on? So this is probably, all right. I'd like to try that. Did I give this to you? No. I've printed the wrong thing. All right. We can all have a look at this, and if you don't mind copying it down, it's my fault. I've forgotten to print it. Why did I do that? All right, we're going to work on this together. I know why I forgot to print it, because this lesson was to be a longer lesson with a backward scan as well. All right, give it a go once you've copied it down, and I will work on my solution, and we will go through it together. You know where to start, the 0 at the top, the first circle. The first obvious thing I look at is that 3. Alright? I know this will go straight. There's only one predecessor to E to 8. So therefore, if this is 4 minutes, that will be 4. Alright? This one's the same. This one, I have to look at those two. So I cannot do anything about this until I go through that circle. What's the answer? 27? Everybody agree? Very good. Yes, I got 27 as well. So, you can see that A is the predecessor of E. So therefore, 4 days, 4 hours, not sure. Should have written down the units, but I did not this time. So 4 is up there. B, G, you've got the predecessor of B, D, and C. Alright? Now, I can't do anything yet. I have to look at this first. So from here to here, that's only D and I. The predecessor of D and I is C. So that will give me 5 in this vertex. Alright? From here, B G, the predecessor is B and D. Alright? But here I need 10 hours before I can complete this loop. Correct? So here I must complete this first before I can start G. So B, you can see that there's a bit of a slack there. You can start a little bit later. Correct? But you must start this C and D, and that will be 10. That will be the earliest time. Alright, from here to here. 12 plus 7 is 19, whereas 10 plus 11 is 21. So maximum is here, there. 5 plus 7 is 12, but you've got 21 plus 6, 27. So that is the maximum. That's the earliest completion time, which is 27 minutes or 27 days, whatever. Alright, I'm going to stop here. Got a few questions in club for all of you to try the forward scanning. Alright, and then I'll talk about the backward scanning, looking for the latest start time and the critical path on Monday.